The world of medicine has seen its share of miracle cures, from the polio vaccine to heart transplants, but all past achievements may pale in comparison to the work of Dr. Alice Crippen. Thank you so much for joining us this morning.
Not at all.
So, Dr. Crippen, give it to me in a nutshell.
Well, the premise is quite simple. Take something designed by nature and reprogram it to make it work for the body rather than against it.
You're talking about a virus.
Indeed, yes, in this case the measles virus, which has been engineered at a genetic level to be helpful rather than harmful. And I find the best way to describe it is if you can imagine your body as a highway and you picture the virus as a very fast car being driven by a very bad man, imagine the damage that car could cause. But then if you replace that man with a cop, the picture changes, and that's essentially what we've done.
Now, how many people have you treated so far?
Well, we've had 10,009 clinical trials in humans so far.
And how many are cancer-free?
10,009.
So you have actually cured cancer?
Yes, yes. Yes, we have.
The world of medicine.
Yes, ladies and gentlemen, I thought that was needed. 100% of cancer patients cured long-term in remarkable human trial. We'll have to go over this little article. Night vision lenses so thin and light that we can all see in the dark. Now these are fucking cool, you have to admit. There's no way I could not talk about these. And that's what I'm going to do. Welcome to the channel. This is Media Mayday. Smash the like and subscribe button if you're into this kind of thing. If not, don't. In what researchers have called an unprecedented response, a new drug that treats locally advanced rectal cancer is shown to have completely eradicated tumors in all 42 patients who took part in the phase 2 trial. The drug, Jemperli, had earlier shown great potential for eliminating mismatch repair deficient dMMR cancers, which make up 5 to 10% of colorectal cancers. Following the phase 2 trial, the first 24 patients assessed showed a sustained complete clinical response, no cancer evident, after an average of 26.3 months. These findings demonstrate the potential of dostarlimab-gxly as a novel approach to treat locally advanced dMMR rectal cancer that leads to durable, complete tumor regression without the need for life-altering treatment. As a clinician, I've seen firsthand the debilitating impact of standard treatment for dMMR rectal cancer, and am thrilled about the potential of dostarlimab-gxly in these patients. The drug is a hugely promising first-line treatment option, bypassing the need for chemotherapy and radiation. Right now, while traditional treatment is effective, it's incredibly invasive, and the impact long-term quality of life. And ultimately, a third of the patients will see cancer metastasize and become terminal. We're going to skip down here. The results of long-term follow-up examination presented in 2024 American Society of Clinical Oncology. The statement, GSK, said patients did not experience side effects above the grade 3, which most experiencing mild or moderate adverse reactions. The company noted that the drug's safety and tolerance is consistent with the known safety profile of the agent. 42 patients is remarkable. These results bring us one step closer to understanding the potential dostarlimab-gxly intent. Yeah, 100%. And where do we see that before? Another 100%. And this is also a vaccine and some sort of a whatever it is. I think this is the same thing my brother's doing, but I don't know. I've seen some other studies done with just vitamins, minerals, nutrients, and enzymes, and it seemed to cure it out a lot faster. Let's go over this one here. Night vision lenses so thin and light that we can all see in the dark. These are badass. From evening drives and navigating a house or a park in the dark, there are so many situations where it'd be handy to slip on a pair of night vision lenses, and that the worlds that beyond human optical perception could be illuminated like never before. This vision could be a reality with a technology breakthrough that could deliver the elusive view to everyday consumers with ultra-thin film and lenses width of the cling wrap. The ARC Center of Excellence for Transformative Meta-Optical Systems, TMOS, in Australia have been on a quest to make night vision accessible and wearable. Looks like they've got it. Having an everyday pair of night vision spectacles to look through reading or driving, yeah, that would be cool. So why aren't we already walking around with our night shades on? Traditional night vision involves a complex system. Let's see, light photons pass through the objective lenses in an electronic image in-transferring tube made up of two important parts, the photocathode and the electrons. Into electrons then flow the microchannel plate made up of millions of holes to massively multiply electrons. Next, the electrons land on a phosphor-coated screen, which they hit the phosphors, and they glow green, illuminating the scene being viewed through the night vision system. So here's a picture of it. Normally they got to be really thick, but TMOS usually a metasurface-based up conversion technology, which essentially provides an easier pathway for light protons to be processed. The photons travel to a resonant metasurface where they mingle with a pump beam. The non-local lithium niobate metasurfaces boosts the energy of photons and draws them into a visible light spectrum without the need to convert them into electrons first. It also doesn't require cryogenic cooling, which reduces noise for sharper images in traditional night vision. I just want to know what the quality is. These results are promising significant opportunities for surveillance, autonomous navigation, and biological imaging industries. Yeah, it's a game changer. This is the first demonstration of the high resolution up conversion from 1500 nanometers infrared to visible 550 negative newton meters. I'm guessing that's what that is. Newton meters light, non-local metasurface. The latest work improves on their previous research into night vision using gallium arsenide metasurface. People have said that the high efficiency up conversions that infrared to visible is impossible because of the amount of information not collected due to the angular loss that is incoherent in non-local metasurfaces. We overcome these limitations and experimentally demonstrate high efficient image up conversation. Now I can't tell you what the fuck any of that means, but I can tell you right now, cool. That would be awesome. I mean, just the ability to just slap on a pair of glasses like that and just see at night with, that would be quite the advantage in a lot of scenarios. Again, guys, we're getting close to all kinds of things on planet Earth, and let's just hope that I Am Legend or the Omega Man isn't one of them. That's one we want to avoid. Anyway, toodaloo.